Hi everyone, this is Ruyue, and this video is for homework 10, question 1. It asks us to collect the definitions and the simple properties of the following stochastic process. Okay, now let's take a look at the first one, the Poisson process. It is defined by the following properties. The first is that the probability of the number of calls received in time t hours equals k. Where this t is fixed. This probability is equal to e to the power of negative lambda time t lambda t to the power of k divided by the factorial of k. This is a probability distribution function. The second property is that the points in non-overlapping intervals are independent, which means that T1, T2, T3, T4. Those time, which is T2 minus T1, and those time, which is T4 minus T3, independent. Okay, so we could see that its first order probability masses can be written as pxt equals k equals this, right? And its mean value, its expected value equals lambda t. Its autocorrelation equals lambda square T1, T2 plus lambda times the smaller value of T1 and T2. And its autocovariance equals lambda square T1, T2 plus lambda times the minimum of T1 and T2 minus lambda T1 times lambda T2. And those two items are equal, so the final is lambda times the minimum of T1, T2. Right. Okay, that's the properties of Poisson process. The second is Poisson increment process. It is defined as yt equals xt plus epsilon minus xt divided by epsilon, where xt is Poisson process. Okay, so its first order probability mass is Pyt equals n over epsilon. This is equal to e to the power of negative lambda epsilon times lambda epsilon to the power of n divided by the factorial of n. And its mean value EYT equals lambda. And its autocorrelation Hw10 Q1 equals lambda square when the absolute value of T1 minus T2 is greater or equal to epsilon, equals lambda square plus lambda over epsilon minus lambda times the absolute value of T1 minus T2 divided by epsilon square when T1, the absolute value of T1 minus T2 is less than epsilon. And its autocovariance can be written as right. The third is Poisson impulses process. It is defined as and also xt is a Poisson process. So its mean value EZT equals lambda, and its autocorrelation Hw10 T2 is equal to lambda square plus lambda right, and its autocovariance is equal to this. The fourth is semi-random telegraph signal. It is defined as xt equals. Also, it is based on Poisson process, right? So the number of calls in interval T1 and T2, this number equals k. So xt equals 1 when this k value is even. In 0 to t, right? And it is equal to -1 when k is odd. In 0 to t. So its first order probability matrices when x equals t, when xt equals 1, this is equal to e to the power of negative lambda t times this. And when xt equals -1, right? So its mean value ext. This is equal to e to the power of -2 lambda t. And its autocorrelation RT1, T2 is equal to e to the power of -2 times lambda times the absolute value of T1 minus T2. And its autocovariance is equal to this. Right, okay. The fifth is random telegraph signal. It is defined based on semi-random telegraph signal. Yt equals axt, and where xt is a semi-random telegraph signal. and the probability of A equals 1 is equal to the probability of A equals minus 1 is 1/2. So its first order probability method can be written as the probability that Yt equals 1, we know it is equal to the probability that Yt equals minus 1, which is 1/2. Right. And its mean value EYT equal to 0. Its autocorrelation Hw10 Q1 equals e to the power of minus 2 lambda times the absolute value of T1 minus T2. And its autocovariance is also this one. So the next is the random walk. It is defined in a background of tossing a fair called n times, right? So the number of heads equals k. So x and t equals ks minus k n minus k times s, which is 2k minus n times s. Its first order probability method is that pxnt equals rs. Is this, right? So its mean value is 0. Its autocorrelation Hw10 Q1 is the minimum of n and m, and its autocovariance Ct1 T2 it is same to its autocorrelation, similar with the previous one, which is this. The next is Wiener process. It is defined based on random walk. Wt equals this, right? Where xt is random walk. Its first order density function can be written as this, and its mean value is also 0. Its autocorrelation equals the minimum of T1 and T2 alpha. Its autocovariance is also this one. So okay, that's all. The properties and the definition of those 7 stochastic process. So thank you.